Alright, today I'll be talking about Gaussian elimination, which is using matrices to solve systems of equations. So, our first example, I'm going to do two equations, two unknowns, and three equation, three unknowns. But we'll get there. First thing we want to do is convert this to a matrix. 17, negative 14. Just copying the coefficients from the equations into a matrix. And number in front of x is 1, negative 8, 15. So pretty much we have an x column, a y column, and then a constant column on the other side of the equal sign. If it doesn't look like that, you have to rearrange it so it does. So our goal in the end is to get everything on this side to look like this. 1, 0, 0, 1. And what that's going to do is pretty much give us x equals whatever number x is, and y equals whatever number y is. So the first thing we want to do is get a 1 up in this top corner. So to do that, we can just flip these around. Always use the easiest way to get to the next step. Since we're trying to get 1 up here, but we're just dealing with two different equations, we can flip them around however we want. So just go ahead and flip the two equations around. 1, negative 8. Make sure you bring everything with it. And this we'll just bring down here. 17, negative 14, and 11. So now we have to start making it look like this. And it's called elimination for a reason, because we use elimination to manipulate these equations, or the matrix. First thing we want to do, and I'll bring this down here, is we want to make this 0. So we know that's what we're going to do. We're going to make it 0, but it's going to end up changing this equation. But this one, the top one, is going to stay the same. So we'll just leave that for now. Negative 8, 15. But the bottom one will be changing. We just know we're making that equal to 0. Now, to do that, what we're going to have to do is multiply our row 1 times negative 17. So when we add it to row 2, that'll become 0. So we go ahead and do that. We are multiplying our first equation times negative 17, and then we're adding it to the second one and putting it in this matrix. So we have 1 times negative 17 is negative 17 plus 17 is 0. So that's how we got that 0 there. And we do the same thing with the negative 8. We have negative 17 times negative 8. 17 times 8 is 136. And we're adding it to this. So we have negative 17 times negative 8 is 136 plus negative 14, so minus 14. So what's going to go here is 122. And we're doing that same for here. Multiplying this times negative 17. 15 times negative 17. 7 times 5 is 35. That's 105, add a 0, 5, 1, 5, 5, 2. Alright, and then remember we are adding it to this. So we had negative 17 times 15, that's going to be negative 255, and we're adding 11 to that. So negative 255 plus 11 is negative 244. Alright, we don't really need this. Our next step is to try and make this a 1. Alright? And then once we make that a 1, it's going to be easy to get rid of this and make it a 0. So we're just going through the steps, trying to get 1, 0, 0, 1 in the matrix on the left-hand side of the bar. Well, to make that a 1, best way to do it is to divide both of these by 122. So all we did was we took our 2 and we divided by 122. Everything else is going to stay the same. So our first row doesn't change again. 1, -8, 15. And we're dividing both of these by 122. That gives us 1, -2. Now, we have to take that and we have to make this one 0. Okay? But to do that, we have to multiply row 2 by 8 and then add it to it because we're using elimination. So we're multiplying that through it and then we're adding it to row 1. And then that's going to give us our final matrix. So that'll give us, once you find 1 and 0 in one column, those aren't going to change. The bottom one's staying the same because we're using it to manipulate the other. So we multiply this by 8 and then add it to this one. So 1 times 8 is 8, minus 8 is 0. So that's what that one will become. Doing the same thing here, multiplying this by 8. -2 times 8 is -16. And then we're adding it to this one and replacing it. -16 plus 15 is -1. So we just found our answer. That gives us our x value, because this is our x column and y column. Pretty much gives us 2 equations. X equals -1 and y equals -2. Okay, our next one, quite a bit harder when you're dealing with 3 equations, 3 unknowns. So, just like last time, our goal is to get a diagonal of 1's here and everything else to 0, and that's going to give us our 3 answers. So that's going to give us pretty much a coordinate point, x, y, and z. So first, we need to copy this as a matrix, and I'm going to write smaller so we can fit it all. If there's no z, that means the coefficient here is going to be a 0, followed by 4, -4, and 9. So, first step, we needed 1 up here, we already have that, so that's good. That's got to be a 1. Our next step is to try and make these next 2 zeros. Okay, so we know we're going to do it, we just got to figure out how to do it. Since we're manipulating these 2, this one's going to stay the same. So wherever you get that 1, that one's going to stay the same for the next step. We have -2, 1, and 4. Everything else is going to be changing. So, if we need to add this to get this to cancel out, this has to be a -3. So we're pretty much using elimination. We're going to have to multiply row 1 times -3 and add it to row 2. So row 1 times -3, we're adding it to row 2. So we'll do that first. So we have row 1 times -3, that's 1 times -3 is -3, -3 plus 3 is 0. So that's how we get that there. -2 times -3 is going to be +6. 6 minus 4 is 2. Then we have 1 times -3 is -3, minus 6 is -9. And then the last one, 4 times -3 is -12, minus 4 is -16. Now the reason this gets bad is because sometimes you have to deal with a lot of fractions. For our second row, we need to cancel out a 2. So we have to multiply this by -2. So we have row 1 times -2 plus row 3. And that's going to cancel out that first one and give us 0. because we have negative 2 times 1 plus 2 is 0. Then we have negative 2 times negative 2 is 4, plus 1 is 5. We have 1 times negative 2 is negative 2, plus 0 is negative 2. And then the last one, 4 times negative 2 is negative 8, plus 9 is 1. All right, next step. So we're taking this down to here. Next step, we need to get this guy to be a 1, so we can manipulate these two equations. So if this guy has to be a 1, we're going to have to take row 2. So from this step to this step, we're taking row 2, and we're dividing by 2. Everything else is going to stay the same. So we have 1, negative 2, 1, 4. Dividing everything in row 2 by 2, everything else stays the same. So this is going to be 9 divided by 2. We'll keep it as a fraction. That's fine. Negative 16 divided by 2 is negative 8. And then the last row stays the same. 0, 5, negative 2, 1. Now, once you get 1, 0, 0 in a column, or all zeros and ones, like this, or this, or this, that's not going to change anymore. So you don't have to worry about it anymore. That's the good thing about Gaussian elimination. Alright, so we have that 1 here. Now our next step is to get these to be zeros. So, we have 1, 0, 0. Now we need 0, 1, 0. So we have to multiply this guy by something, so that'll cancel out. And the same for row 3. So, remember, whatever has the 1 here is not going to change. So we can keep that. Negative 9 over 2 and equals negative 8. Everything else is going to be changing. So, for our first one, we're trying to get rid of a negative 2, so we have to multiply this by 2, because 2 minus 2 is 0. So, take row 2, and we're multiplying by 2, adding it to row 1. So, this one times 2 plus negative 2 is 0. Perfect, worked out. This one times 2, negative 9 over 2 times 2 is actually just negative 9. So we get negative 9 plus 1 is negative 8. Negative 8 times 2 is negative 16. Negative 16 plus 4 is negative 12. For the second part, we need to multiply this by 5, but actually not only 5, negative 5, so it cancels out with this. So we multiply row 2 times 5, negative 5, and then adding it to row 3. Because we're trying to get this guy to be 0. So we go ahead and do that. Multiplying this times negative 5, negative 9 over 2 times negative 5 is going to be positive 45 over 2. And we're adding that to negative 2 over 1. 45 over 2, I'll do the math over here, minus 2 over 1. Well, we have to multiply this by 2. That's going to give us 41 over 2. So 41 over 2 there for now. And then, we'll do the same thing here. We're multiplying by negative 5, adding it to negative 8. So we have negative 5, we're multiplying row 2 times negative 5. Negative 8 times negative 5 is 40, plus 1 is 41. Now that's done. Remember, our next step is to get a 1 here. We need 1 in all the diagonals, but you can't get that 1 there until you're done with these columns. If you get it there, you're going to end up ruining the 1 by the end. So you want to get that when you have to. So to get this to be a 1, we have to multiply that.
Cameron Gilbert, please come to the front office. Cameron Gilbert, please come to the front office.
To get this to be a 1, we have to multiply that by 2 over 41. So from this step to this step, we're multiplying row 3 times the reciprocal of that, 2 over 41. And that's going to clean things up for us a little bit, actually. So we get, everything else stays the same. We're multiplying the third row by 2 over 41. That's going to give us a 1 here. And 2 over 41 times 41 just gives us a 2 here. So pretty much we just solved z. Now we got to get zeros here, which is going to be the hard part. But not too bad because we're pretty much done by this point. So, in the end, we're going to have just what we wanted. 1, 0, 0, 0, 1, 0, 0, 0, 1, and then our answer. But we have to figure that out first. And remember, this one's already done. We have 0, 0, 1, 2. So, to get rid of a negative 9/2, we have to multiply this by positive 9/2 and add it to that. So, for our first one, we're multiplying row 3 times 9/2, and we're adding it to row 2. And that's going to give us our y. So, negative 9/2 times 1 is 9/2, minus 9/2 is 0. Perfect, that worked out. And we have 9/2 times 2, which is just 9, minus 8 is 1. And then the last one, we are multiplying row 3 times 8, so we can cancel that out. And then we're adding it to row 1. And that will give us our final answer. This times 8 is 8, minus 8 is 0. Good, that one checked out. Then we have 2 times 8 is 16, minus 12 is 4. So our answers, finally, are from here, x equals 4, y equals 1, and z equals 2. That's it for today.